Today's topic is the parameters used to define the behavior of electrolyte under the influence of electricity. These are six parameters, that is resistance, specific resistance, conductance, specific conductance, equivalent conductance, molar conductance. By using these parameters, we can define electrolytic conductor as well as electronic conductors also. Let us see about resistance and specific resistance. Resistance. Resistance refers to the opposition to the flow of current. In other words, it can be defined as the reciprocal of conductance. That means reciprocal of flow of current. Mathematically, it can be represented as R is equal to 1 by C. We have to understand that R is equal to resistance, C is equal to flow of current. Specific resistance. This refers to the opposite to the flow of current per unit length and unit area of cross section. Here, this can be denoted by rho. Rho is equal to R into A by L, where A is equal to area of cross section, L is equal to length. Units per specific resistance is ohm meter. Units per specific resistance is ohm meter. So I am repeating the units again. Units per resistance is ohm. Units per specific resistance is ohm meter. Let us see about conductance, specific conductance. Conductance. Conductance refers to that of reciprocal of resistance. And in other words, it can be defined as the capacity of a substance to pass the current through itself. Conductance is denoted with C. Mathematically, conductance can be represented as C is equal to 1 by R. Units for conductance are mho or Siemens. Using Siemens is more comfortable than mho to avoid the confusion. Specific conductance. Specific conductance refers to that of reciprocal of specific resistance. Specific conductance refers to that of reciprocal of specific resistance. In other words, this can be defined as the conductance of the substance having unit length and unit area of cross section. It is denoted with K. In Greek, K is called as kappa. Units for specific conductance are mho per meter or Siemens per meter. I am repeating the units again. Units for conductance are mho or Siemens. Units for specific conductance are mho per meter or Siemens per meter. And the most important parameters are equivalent conductance, molar conductance. Equivalent conductance. This can be denoted by delta E. In some books, it has represented as lambda. In some books, it has represented as delta. Here in delta E, delta represent conductance, E represent equivalence. Okay. So let us define this. The conductance of 1 gram equivalent of the electrolyte dissolved in VmL of the solution. The conductance of 1 gram equivalent of the electrolyte dissolved in VmL of the solution. The V may be 1000 ml, 500 ml, 250 ml, any means. Mathematically, it can be represented as equivalent conductance is equal to K into V. Here V is equal to value. In other words, it can be expanded like this. Delta E is equal to K into 1000 by N, where N represents normality. Units for equivalent conductance. Siemens centimeter square per equivalent. I am repeating again, units for equivalent conductance are Siemens centimeter square per equivalent. Molar conductance. There is a little bit difference in the definitions of equivalent conductance and molar conductance. Conductance of 1 gram mole of the electrolyte. Conductance of 1 gram mole of the electrolyte dissolved in VmL of the solution. Let us see the difference. In equivalent conductance, we have stated that 1 gram equivalent. In molar conductance, we are stating that gram mole of electrolyte. This can be represented as delta M. Delta M is equal to K into V. Here K represents specific conductance. V represents value. In other words, it can be represent K into 1000 by M. Here M is equal to molarity. There is a small difference between the units of equivalent conductance and molar conductance. Let us see. Siemens centimeter square per mole. I am repeating again. Units for molar conductance are Siemens centimeter per mole. These are the most important terms. That is equivalent conductance. I am repeating again. Conductance of 1 gram equivalent in the of the electrolyte dissolved in VmL of the solution. Molar conductance. Conductance of 1 gram mole of electrolyte dissolved in VmL of the solution. Based on these parameters, we are going to discuss about Kohlrausch law in future learnings. Thank you. Happy learning.